Hello, I'm Richard Guidorizzi. I'm a program manager at DARPA in the Information Innovation Office, I2O. We're discussing a program that I have called the Active Authentication Program. The purpose of the program, well, let's start at the beginning. Everyone knows there's a problem with passwords. I used to be an IT director at DARPA beforehand in a previous life, and this was a problem I had to deal with on a regular basis. The Active Authentication Program is intended to move us beyond passwords to go to the point that we can just sit down at our consoles and start working with the computer without it interrupting us and stopping us when we're doing things, just allow us to continue moving forward. The Active Authentication Program is doing this obviously by using biometrics, because biometrics are the only things you have that's available. But the difference between existing biometrics and what we're focusing on here is we're focusing on the attributes of the individual that can be captured from the computer as it stands in the DoD environment, which means no cameras, no extra sensors, no voice recorders, just the keyboard, the mouse, and the computer itself, and the data you can get there. There's plenty of information that's there, but the field of biometrics right now seems to be more heavily focused on what you can capture using a sensor. Things you can pull when you've got a fancier camera that can do this, or a sensor that can pick up your voice or fingerprints and things like that. The first phase of this Active Authentication Program is trying to increase the amount of research that's being done in the areas beyond that. We have individuals inside the program that are looking at stylometry, which is the analysis of how people use language, where they can use the pauses that you have between when you're typing words and use that to determine the individuals of the keyword. We're trying to find other ways of doing biometrics that are beyond just the use of sensors. The problem is the fact that passwords get compromised on a regular basis. We hear on the news about passwords on systems being compromised all over the place, systems get accessed, and the reality of the fact is, because passwords have to be created by humans, there has to be a pattern to it, because that's how we remember things. We can't just remember random sets of characters. That's not the way humans are built. We're built to remember patterns. So if you develop a pattern, a computer is going to be able to develop a program that can find the same sort of pattern. So when an external site gets hacked, and the first thing the attackers take is they take your email, they take your ID, they take your password, because they're thinking, if I get an ID and password here in an email and I find another site, then I can use that ID and password. And even if I don't know what it is, I get the idea. If you always put your first name and then a location and then numbers afterwards, they'll use that as a pattern to do it, because people use patterns to remember the passwords. And when you get those patterns, DEF CON every year has a password cracking contest that's coordinated by CoreLogic. And each year they go with more and more sophisticated techniques, and they crack passwords faster and faster on larger scales, showing that it's just a matter of how much time you have to expend to get to a password, because a password's always going to get compromised. The Active Authentication Program is saying, no, let's go beyond that and let's move to something else. The problem I had when I was doing the research is the biometrics industry exists already. There's information out there showing that we do have the ability to use biometrics to pull those features, but no one's using it on a large scale. It's being used in isolated cases, and there's an industry that's trying to move forward, but pretty much everyone is using ID and password across the board as their standard methodology. Now, when I did my research, I felt that the reason why this was happening is because when you look at biometrics and you engage in a discussion with it about how useful fingerprints are, they always comes up with, well, a fingerprint can be spoofed by a Play-Doh fingerprint. An iris can be spoofed by taking a picture of an iris in a certain way with a certain camera, and then you can spoof the camera. It always comes down to this biometric can be bypassed because it's a physical biometric by another physical device. In the Active Authentication Program, we try to move past that by connecting together multiple biometrics. And not only connecting multiple biometrics, we also put them in context, so that when you're typing, it's looking for typing input. When you're using your mouse, it's looking for mouse input. When you're surfing the web, it's looking for web input. And if you're typing inside a Word document and the computer all of a sudden says, wait, I'm getting mouse input, the platform that we're developing would go, wait, you shouldn't be getting mouse input when he's typing in a Word document. There's an adversary and they're trying to do something inappropriate. And that way we can use these things to say the context matters, and the information will defeat replay attacks and make it much harder for somebody to get into the systems. Okay. The challenge that we have with replacing the authentication solution that we have right now, in addition to the fact that there's ID and password everywhere, is how do we get something that's going to work consistently and can convince the CIOs of the world to replace their trusted, even though it's got some, it has some flaws in passwords and IDs, but they know what the weaknesses are, and the CIOs of the world are basically conservative people, because when you're a CIO, you get when things are going well, nobody notices, and when things are going poorly, you lose your job. So that's basically, it tends to create more conservative people. So when you're more conservative, you take less chances, and they have to get an understanding that this solution and other solutions like biometrics can have a chance of giving them the same level of security that we get through this. And as I mentioned before, the connecting together of multiple biometrics allows us to increase the fidelity of every individual biometric. It doesn't let us rely on a single biometric. If you're doing several things at once and one of the biometrics kicks back and says, hey, this isn't you, there's several other areas where the computer will be able to check and say, is this really you? Okay, the fingerprint scanner says you're not typing in the same pattern. Is it because you just banged your finger, or is it because somebody else is using the keyboard? Let's see what the mouse dynamics pick up. Let's see what stylometry picks up. Let's see what various other things. And in later phases of the program, we'll have this developed open enough that yes, you can plug a camera scanner on it if you have a camera, if there's some sort of circumstance. I don't expect that to happen in DoD very often, but there may be circumstances where they do. They may have fingerprint scanners already deployed in a location. And we will have the ability to integrate all biometrics by trying to develop an open solution that can take anything in. It's just the key is going to be managing the risk associated with who's there. Because when you're talking to a CIO, they see a biometric and say, that doesn't give me 100% viability that that person is there. I feel like I have 100% with my CAC. I feel like I have 100% with my password and ID. So this system will say, okay, you determine the level of assurance you can give to this biometric, and you build it into the system as it goes with the system administrator configuring the system. And then we will give you a level of risk and say, I can trust with this fidelity because I checked this many times that this person is the right person at the keyboard. And that will take, currently there is a market for risk-based authentication systems out there which focus on attributes of a session. They do things like, okay, if you just Facebook uses this for example. If you log in one city and your Facebook on a normal desktop, and then all of a sudden you log in a different desktop in a different city, it's going to flag it going, wait a second, are you really the same person? This is not an uncommon thing, but it doesn't actually look at the attributes of the person, it looks at the attributes of the session. We're trying to get it to look at the attributes of the individual so that we can capture that and bring that in, which makes it much harder for an adversary to bypass our system, giving a better assurance to the CIOs of the world that you are the one sitting at the keyboard and we can trust that. Another thing we need to address is the privacy concerns associated with how these systems are used. Because I'm talking about taking a biometric. We are talking about developing a system that validates you are who you say you are, not a system that identifies who you are. It's not the same thing as trying to say, when social websites can take a picture and determine who you are based on the picture. That's not what we're trying to do. We're trying to say, I put my CAC into the machine. Am I really who I say? Is this Richard who's using the computer right now? And it compares against just to say, is this it? An additional thing that we're going to do to add another layer of privacy controls is we're going to do the processing on the local machine. So when the system does the processing of your biometric features, whether it be keyboard typing or various other things we're looking at, it does the processing locally to develop a hash that it uses that will send back the central system that will go compare that to your registered information to see that when you register your system, did you have the same thing? That way we're not sending who you are back and forth. We're just developing an encryption key basically that will come from the machine to the server. So we're not passing attributes of you back and forth, because if we did, not only would it be a lot slower because it would be a lot more data, we also give the opportunity for an adversary to try and grab that and then try and use that in another session. That way we protect the individual and we focus on what we're trying to do, which is identifying you are who you say you are, not trying to figure out who's at the keyboard. Just are you who you say you are.